All right, today we're going to do lesson 11.8. We're going to solve rational equations and functions. Let's review one more time the word rational. Numbers that are rational are numbers that can be written in what form? Fraction form, okay? And equations, we're going to look at equations today. So what are we going to see today that we have not seen so far? Equal signs. We've been dealing with expressions. Today we're going to solve rational equations. Now there's two ways that we can do this. We can either solve rational equations by cross multiplying, which hopefully this is a quick review for you. Or the second way we're going to learn is by multiplying everything by the LCD, or the least common denominator. But let's look at cross multiplying first. Who remembers, who can raise their hand and tell us how we're going to cross multiply this problem? All right, Jacory.
X factor.
Okay. Tell me exactly what I'm going to be multiplying in order to cross. Okay, I'm going to cross and I'm going to multiply my 5 and my x, which anytime I'm multiplying a number and a variable, there's no reason to put a dot between them. Okay, we can simply put the number and the variable side by side. All right, what's the next set of things that I'm going to multiply?
10 and 14.
All right, I'm also able to multiply 10 times 14. So we're going to write that down. And what needs to come down into the middle of the two expressions? The equal sign. All right, you would be surprised how many people forget to drop that equal sign down. So I'm going to ask you every single time, and you're going to tell me, bring down the equal sign. All right, now we're going to do the math. 5x equals 140. And this is a simple equation that I have to solve. So read, how do I solve for x?
Divide each side by 5.
I'm going to divide each side by 5. So x equals? Mason?
28.
28. Awesome. Okay? Now, letter B is a little bit more difficult for some people because when we cross multiply, we're actually going to be multiplying a number and a binomial. And people make a very simple mistake. So let me show you what not to do. All right? What you don't want to do is you don't want to cross multiply and write down 5x plus 4. If you do that, you have the wrong expression. So remember, when you're multiplying a number or a monomial of any type times a binomial, that you always want to put the binomial in parentheses because it's 5 times x plus 4. And we've learned in this chapter, x plus 4 is one piece. It's not an x and a 4, it's x plus 4. So we want to make sure we keep those binomials in the parentheses. Now, what happens when we cross multiply 5 times 3 times x plus 1? All right, what can we actually do first, Michelle? You can go ahead and do the 5 times 3. I'm okay with that. And what is 5 times 3? 15. And then, of course, we're going to keep the x plus 1 in parentheses. All right? So you can go ahead and do the 5 and the 3 because they're outside the parenthesis. 5 times 3 is 15. But keep the binomial in parentheses. And then what are we going to drop down between the two expressions?
Equal sign.
That equal sign. Awesome. All right? So what happens, Peyton, on the left side of this problem? What are we going to multiply?
5 times x plus 4.
Okay, we're going to do 5 times x, which is going to give us 5x. And then we're going to multiply 5 times 4 and get positive 20. Awesome. On the right side of the problem, Javion, what are we going to get?
15 times 50x plus 15.
Good. 15 times x is 15x. 15 times 1 is 15. So don't forget to distribute. Now, remember the sentence that I taught you to help you remember, because this is a multi-step equation. Does anybody remember the sentence that we learned many chapters ago? Ian?
That's not a sentence. Nope, I don't know. Nope.
All right. Mason?
Please excuse my dear Aunt Sally.
That's PEMDAS. Okay, but that's not the sentence that will help us with equations. That is one we've learned.
The planet one?
No, Jacory?
Something I can't go after 5. Or somebody.
Don't call me after midnight.
Alana, don't call me after midnight. So we've already distributed. That's what we just did. We're then supposed to combine any like terms. Do we have any like terms to combine? No, not right. They have to be on the same side. We don't have any. So now we're at the M, which is to move the variable. Do we have a variable on both sides of the problem? Yes, so we want to move one of them to the other side. Which direction are we always trying to move our variable? To the left. So if we're going to do that, then Kayla, which one do we need to move? The 5x or the 15x? If we're trying to get the variable to the left. 15x. And how are we going to move it to the other side? We're going to subtract it. Awesome. So we're going to subtract 15x from its like term, which is 5x. So we cross that out. 5x minus 15x, negative 10x. Bring down plus 20 equals 15. All right, don't call me after. The A in after stands for adding or subtracting. So which number can be moved by either adding it or subtracting it? Ian? Say it again. 20. We're going to move the 20 to the other side. So how do we move it to the other side? We're going to subtract it. Good. So we have negative 10x equals negative 5. All right, and then midnight. That's multiply or divide, depending on what's left. So Peyton, what's left to do in this problem? Divide both sides by? The negative 10. So Peyton, what is my final answer going to be? Is it going to be negative?
Negative 1/2.
Is it going to be negative though? I got a negative 5 divided by a negative 10. When I divide two negatives, I get
A double negative.
So I get a what?
Positive.
Positive. So my answer is x equals positive 1/2. Because remember, we always reduce our fractions. Hey, any questions on example number 1? This, hopefully, like I said, is just a reminder, a review of cross multiplying. All right, now let's look at example 2. The second type of way that we can solve rational equations is by multiplying each side by the LCD. What does LCD stand for?
Least common denominator.
All right, which also has been called least common multiple. All right, so when you're looking at letter A, you're looking at every denominator, and just like yesterday, we're trying to make sure that every denominator is in its final factored form. We cannot figure out a common denominator until we have made sure that our denominators are in their factored form. So obviously x, 3, and x, we cannot factor any further than they are. So now we've got to decide what's our number part of our LCD. How many numbers do you see? 1. What is it?
3.
So 3 is the number part of our least common denominator. Now, we learned yesterday that pairs get used once. Do you see a pair of anything? Yes, we have a pair of x's, so they get used once. So our common denominator is 3x. Now, watch what we do with the 3x. We are actually going to multiply every single term in our problem by 3x. So you wonder, why is she putting it up there next to the numerator? Because I could make 3x a fraction by putting it over what? 1. And we could rewrite each problem and say 3x over 1 times 2x. But nobody wants to do that because it takes a really long time. So if you multiply each term by the 3x, just put it up there next to the numerator, and that reminds you it's a numerator. Now, what will cancel? Remember, when we cancel, we're looking for something in the numerator and something in the denominator that can be simplified. So read, looking at 3x times 2 over x, what can we cancel? The x's. We have 1 in the denominator and we have 1 in the numerator. So they cancel. And read, what does that leave us to multiply in the numerator? 3 times 2, which is, so we bring down a 6. Now, if we've done this right, the denominator should go away every single time. If we have chosen the correct common denominator, then the denominator should cancel every time. Kayla, what about 3x times 1/3? What will cancel? I got a 3 in the denominator and I got a 3 up there in the numerator. So what does that leave me to multiply? 1 times x, which is just x. Good. All right. Gavin, 4 over x times 3x. What's going to cancel?
The 2x's.
The x's are going to cancel, and I'm left to multiply
3 and 4.
3 and 4, which is 12. Now all we have left to do is get x by itself. So Isaiah, how do I get x by itself?
Subtract a 6 on both sides.
Very good. So x equals, Isaiah, x equals 6. Very good. Okay, any questions so far? All right, look at letter B. Now again, check those denominators. We've got an x plus 9 and an x plus 9. Can either of those be factored down further?
No.
No, they're not binomial. I mean, they're not difference of squares. There's no GCF to pull out. So x plus 9 is as factored as it's going to get. So what is our GCF going to be?
9x.
1x.
All right, now let me ask you this. Okay, I've got 3 different answers.
1.
I'm not changing. If it's in its factored form, I'm looking for pairs, first of all. Do I have a pair? So why are we changing it to 9x and x plus 1? It's x plus 9. All right? The pair, I've got an x plus 9 here and an x plus 9 here. The pair gets used once. So x plus 9 gets multiplied by every single term. Now, you say, Ms. Johnson, the 2 isn't a fraction. It doesn't matter. The LCD gets multiplied by every single term in your problem. All right, now let's go through and see what cancels. Michelle, look at letter B, the first part. I've got x plus 9 times x over x plus 9. So what's going to cancel? The binomials. I got one in the numerator, one in the denominator. So they cancel. And that leaves me with what, Michelle? X. Bring down your equal sign. Bruce, x plus 9 times 9 over x plus 9. What's going to cancel? I got one in the numerator, one in the denominator. So that leaves me with 9. All right, but what happens when it's a 2? Will anything cancel? No. So what do I do when I have 2 times x plus 9? Peyton?
Make it a fraction or
No, it's 2 times x plus 9.
then you bring it down. 2 and then
No. Javion, what am I going to do? Distribute it. So what do I get when I distribute it? That's what I'll bring down. Plus 2x plus 18. Awesome. Caleb, what's my next step if I'm trying to solve for x? Not yet. Remember, don't call. The C in call stands for combining like terms. Do we have like terms we can combine? What? Good. We're going to combine the 9 and the 18 first. So x equals 2x plus 27. Now, what would you do, Caleb? Okay, how do you move it to the other side? Subtract 2x from both sides. All right. Alana, what's x minus 2x? Remember, this is a understood 1. Negative 1x. Good. And it equals 27. Mason, how would we finish this?
Divide by -1.
Divide both sides by negative 1. So x equals
-27.
negative 27. Great. Good job. Any questions on either one of these? All right, let's look at letter C. Now, I kept it simple in the lesson. All right, we're back to monomials in our denominators. We've got an x, an 8, and a 4. Somebody raise your hand. Let's deal with the number part first. What's our least common denominator going to be? Peyton.
4.
All right, remember, factors fit into numbers, multiples do not. So with the least common denominator, we're looking for the biggest number the two have in common, which would be 8. Because 8 times 1 is 8, and 4 times 2 is 8. So we've got an 8.
Oh, no.
We've got an 8, and then what variable are we going to use in our common denominator?
X.
We're going to use an x. We've only got one of them, so we're going to use it. So we are going to multiply every single term by 8x. All right? So Kamari, if I'm looking at 8x times 2 over x, what's going to cancel?
The x.
The x's. I got one in the denominator, one in the numerator, so what am I multiplying?
8 times 2.
Which is?
16.
Great. 16. Bring down your minus sign. Isaiah, 8x times x over 8. What's going to cancel?
The 8.
The 8's. And that leaves me to multiply what?
The
X times x, which is?
x squared.
Good. Bring down the equal sign. Ja'Cory, what happens when I do 3/4 times 8x? What's going to cancel this time? Now listen, so far everything we've canceled has just equaled 1. That doesn't mean it's the only way to simplify. Okay? It's just a fraction that we're trying to simplify. If we've done it right, the denominator will go away. Doesn't mean the numerator is going to go away completely. But the denominator at least should go away. So what simplifies? Javion? The 8 and the 4. Because what goes into both 4 and 8?
4, 2.
4. Okay? So Javion, 4 goes into itself once, so it goes away. But 8, instead of just going away, 4 goes into 8 how many times? Twice. All right? So that is something that we haven't seen until now. All right? But just keep that in mind. The denominator should go away every time. The numerator might not. The numerator might just cancel out and become a different number. So Javion, 3 times 2x is what? 6x. Awesome. Now, I've got an x squared, an x, and a constant. And I'm supposed to be solving for x. So what are we going to have to do to this problem in order to solve it? Anybody?
Make it equal to 0.
Okay, we got to get this problem set equal to 0 first of all. So we got to get everything on one side. All right, so how are we going to do that? What are we going to move?
Subtract 6x.
All right, now normally, yes. Normally I would say let's do the easiest work, the smallest amount of work possible. Let's move the 6x. However, do we want or can we have a negative x squared when we're trying to factor? No. So for this particular problem, we're actually going to move the x squared and the 16 to the other side. Because if we don't, we're going to have to pull out a negative 1 GCF, and nobody wants to bother with that. So let's move the x squared to the other side. How are we going to do that? We're going to add it to both sides. All right. Bring down the 16 equals. We know that 6x and x squared are not like terms, so we're going to bring down the x squared first and then the 6x. And how do I move 16 to the other side? Subtract it. So 16 minus 16, there's my 0. And I have x squared plus 6x minus 16. Because none of those are like terms, so none of them can be combined. Now, I have a trinomial. What am I going to do next?
Factor it.
Factor it. So let's draw our x. All right, we'll do this one together. But what's going at the top of my x? 6. What's going at the bottom?
Negative 16.
Will my signs be the same or different?
Different.
Good. This is a negative sign, so my signs will be different. I need factors of 16. So 1 times 16, 2 times 8, 3 times 6. Oh, not 3 times 6. 4 times 4. All right, but we found it. What is the number?
2 and 8.
We're going to use 2 and 8.
8's your positive.
8 is positive, 2 is negative. Awesome. So we have 0 equals x plus 8 and x minus 2. Are we done? No, because what do we have to do next?
Put them both equal to 0.
Set each set equal to 0. How do I solve for the first x?
Subtract 8.
Subtract 8. So x equals negative 8. And for the second equation, add 2. And so x equals positive 2. And there you have it. Those are your answers. X is equal to negative 8 and x is equal to 2. Are there any questions? That is 11.8.